In this video, I'm going to introduce the AC method. The AC method is good for trinomials. Personally, I'll often try to factor a trinomial using guess and check for about 15 seconds. And if I can't see a factored form, then I'll shift into the AC method, which will work unless the polynomial happens to be prime to begin with. Here are the steps for the AC method. First, notice you always have to start with your trinomial written in standard form, and you need to identify the values of A, B, and C. Next, we multiply together A times C, that's where the method gets its name, and then we find all factor pairs of that product. We look through those factor pairs and try to find one which adds up to B. And if we do find a pair that adds to B, then the AC method is going to work and the trinomial is factorable. We return to our original trinomial, and the second degree term and the constant aren't changed, but the first degree term will be written as two like terms. And then notice the last step in the process is to factor by grouping. So if you're not already automatic at factoring by grouping, you need to go back and practice that, since the AC method is dependent on you already being good with factoring by grouping. I'll run through this problem so you can see how the process works. First, I need to find the product A times C. For this trinomial, A is 1. We don't see the factor of 1, but it's there. And C is 12. So A times C would be 1 times 12, or 12. And I always keep in mind the value of B, which again is -8. Now I'm going to generate all factor pairs for 12. And I do this using prime factorization. Some students like to rely on a calculator, and that's fine. Just keep in mind it will be slower to use a calculator. Prime factorization is faster. My factor pairs for 12 will be 1 times 12, 2 times 6, and 3 times 4. It's true you can go on to, say, 4 times 3, but it's wasting time. We already have the factors 3 and 4, and reordering them isn't going to make a difference in terms of our answer. Now that I have found all factor pairs of A times C, I find the one that adds to B. Currently, none of them add to B, but 2 times 6 is close. It gives us a positive 8 instead of a -8. That makes me think that if I just saw them as -2 and -6, that would add up to -8. But before I move forward, I need to verify that my pair matches both of the requirements. That is, that they multiply to a positive 12 and add to a -8. And as you can see, they do. That means I can return to my original trinomial. The second degree term won't change, the constant won't change, but the first degree term will be written as two like terms using my pair as the coefficients. So I'll have x squared minus 2x minus 6x plus 12, and notice that these do add up to -8x. Sometimes students are concerned that their order might not be right. That is, they might have put the -6 first and the -2 second. It won't matter. The factored forms will be the same. Now I just factor by grouping. I take out the common factors, and I can finish when I have my product. So again, the AC method is dependent on you being able to factor by grouping pretty well. Well, that concludes this video where I've introduced the AC method. In the next video, we'll work a number of problems where A continues to have the value 1.